All right, let's go over this Unit 2B, descriptive data warm up and practice. Okay, so these are got some really good thinking problems on this. All right, so with this first one, we're asked about which of these statements is true. And so keep in mind that standard deviation and variance are both a measure of spread. Variance is the standard deviation squared. Okay. All right. So what I can see here is that with these two shapes, they're both centered there at the looks like in the same place. They also have the same going from 100 to 180. But I can tell that this one on the left is more closely clustered around the mean, so it has less variability in terms of standard deviation. Standard deviation is that average distance from the mean. Okay, now here, this other one has more data on the outside edges, so that's a bigger standard deviation. All right, now, so here we go. They don't have the same standard deviation, and only one data set doesn't have the gaps. They are both symmetric. They do have the same mean because they are both centered in that same place. Think of it like a teeter-totter. Where do they average out? If you had weights, they'd have equal weights on either side of this line in the middle. And they have the same range. They do not have the same variance. Now, this next one is interesting. Keep in mind it says which of these is a possible result. Okay, so if I know that you have a data set and you take off those outside pieces of data, the variability, the standard deviation, the average distance from the mean has definitely decreased. Okay, it has. So here, this is wrong. It hasn't remained. The standard deviation is not unchanged. The standard deviation variance are not unchanged. E says that the mean and standard deviation have increased. No, they would decrease. Now, some of you struggle with, you got that process of elimination, so you say D, but how can this mean remain unchanged? Well, it is possible that if your outliers were totally symmetric, you took away one that was 10 above and you took away one that was 10 below, then they would still be averaging at the same place. So that could still happen if they were equal distance from the middle. All right, here we have which of these statements is true. Do keep in mind that if 90 and above is an A, most of the students, that's over 50%. Okay, so this is not over 50%. All right, it's not the majority. So we're going to not go with 2 as being true. And then you can see why these other ones, the median is not a 7. I don't know that that's 75. 4 were below and 5 were above 90. So that's not true either. The median data piece is number 7, which is right here in between 80 and 90. All right, number 4. Here we have this. It's skewed to the right. Maybe this is an upper outlier here. And if you have skew, then you must choose to use median and IQR. Okay, so there we have median and IQR. All right, so on this one, I actually put into my calculator these numbers, keeping in mind this is 52, 55, 57. So I put those in and I calculated all the 5-number summary and the standard deviation and such of that. I also put all of these into my calculator to calculate those numbers. So I've listed what's going on here. Okay. You have just got to be able to do that one variable stats calculation in your calculator. Do not expect you to do those calculations by hand. All right, so what comes out then is that the ranges are the same. They both are a range of 46 from high to low, and they are both the same sample size of 22 items, but the others are different. Okay, here, if my mean is 18 and my median is 15, the mean is greater than the median, so it's skewed right. All right, number 7. Now, when you take a look at this problem, make sure here on the left that you are paying attention to the number line direction. Okay, because see here, I can see box plot A is skewed to the left, so you need to turn your head. So I'm like, you need to turn your head so that you are looking at the number line from least to greatest, okay? All right, so here, this one would be box plot A. This next one, centered at 30, and it is symmetric. And so that's either B or C. Okay, so D and E are out. Okay, so let me look at 8 versus 9. Okay, look, also centered at 30, but it has more data on the outside edges. So its interquartile is wider. So that's why number 9 goes with this box plot C instead of B. B is more closely clustered to the center, so that 50 percentile is smaller. All right, moving on. Number 10. Okay, here, this is the key that you have got to know that if each score is increased by 25, mean is affected by addition, standard deviation is not. Okay? Now, what does affect standard deviation? Only the multiplication. So, just FYI, if suppose we had a function that was like y equals 3x plus 10, okay, then the new standard deviation would be 300, not 310. Okay. All right. Next. Oh, here we go. Here's one where it's increased by 25%. So that's this 1.25% multiplier, which that multiplier affects the standard deviation as well. All right. Number 12. Which of these is true? So here we go. So this, what does it say? If these were removed, okay, then we do know that median, knocking off those outliers, the median and the IQR would remain unchanged. Okay. Now, I kind of like had to really think about this one. The standard deviation does definitely get smaller. But now let's talk about what the mean is, what's happening to the mean. If these outliers were equal distance, okay, then that mean would stay the same. But they are not. This outlier is 8 above what's going on here, and this one is 5 below this median or what's going on here. Okay, now keeping in mind, so it's a little skewed to the right, so our mean is going to be, just a tad higher than, so somewhere a little bit higher than that median. Okay, but here's what's happening. The median will remain unchanged. Now, look, the mean, when you take away this one here, it's pulling it up. It's pulling it up more than this one is pulling it down. This one is a stronger pull because it's farther away. So that means that if you take this away, then that mean is definitely going to go down. So it will get smaller because you're taking away a bigger number up top. Going to go down. All right. Next. Okay. Ooh, this one had some really good stuff in it. I think this first one was pretty easy to see. It was skewed to the left, and this was my only skewed left option. So done. That was histogram C. Now, looky here. Here's where it got tricky. These next two. Oh, okay. No. I guess this one, histogram D, it was skewed to the right. Okay. But I was like, which one is it? Is it going to be D or is it going to be A? What's going on here? Okay, so think about it this way. Look, if I look at this picture here, 25% of the data, a whole entire quartile is between 10 and 15. And so is that what's happening here between 10 and 15 on A? No, that is what's happening here between 10 and 15 on histogram D. That's why that's the one that goes with this box plot, this second box plot. Now, look at this one. Centered at 30, symmetric. Okay, so look here. B is centered at 30 and symmetric. E is centered at 30 and symmetric. So I had to really study what's going on here. Okay, so let's take a look at this. What I kind of did was I came over here and I marked. Okay, so I could tell a quartile went from 10 to 20, and from 20 to 30, and from 30 to 40, and from 40 to 50. So the quartiles were equally spaced. So here's the thing. Does this look like 25% of the data just like that? No. Here, this and this are both 25% of the data, just like this and this show 25% of the data. This B would have a smaller interquartile range because the middle 50% is probably just going from 25 to 35. The middle 50% is probably this chunk right here going from 25 to 35, not 20 to 40. Therefore, it is histogram E. All right, next. Here, okay, see I had to go 10 times 15,000, 17 times 20,000, and so on, and divided by, I added this up, 150 pieces of data. So I multiplied them all, divided by 150, and that's how I got 30,533. All right, here we go. Interpret this. Please remember, Y percent of subjects got X amount or less. Y percent of subjects got X amount or less. I'm going to write that down. Y percent of subjects get X amount or less. Okay. All right. So in this case, in context, that is 60% of these drinks at the coffee shop get 30 grams or have 30 grams of sugar content or less. Okay. That's what that point is saying. All right. Here we go. Number 16, 175 patients. So actually, there's total 175. So that median I computed to that's the 88th piece of data. So the 88th piece of data would fall here between 5 and 10. So it has to be B. Number 17, Q2 is the median. Several people asked me this. Is Q2 the median? Yes, it is. All right. Now, I struggled with this problem. I first thought A was wrong. And so then I went and I was looking at all the other ones and I was like, oh, dang. I mean, I knew all of these for sure were wrong. So I reevaluated B. It says at least because I reevaluated A. A kind of sounded right, except for this little like at least thing concerned me because I know half is above 44.27 and half is below 44.27. But this says at least half. So that's what threw me when I first went through this. And so I think it says at least half because it incorporates 44.27 also. So if you have 50% above in addition to your 44.27, then that's a little bit, half plus one more. So that's at least half. And same thing, if you have all the 50% below it, plus, how many 44.7s are there also, So you could have more, you could have 10 numbers that are 44.27. So however many are that median and the ones below, however many are that median and the ones above. That's why it says at least. Okay, 18. All right, very important here. This is your function. Oh, one thing that might have caught you off guard is that the expected value, okay, this is the mean. The expected value is the mean right there. So it's saying the mean is 19.25. The standard deviation is 5.76. It didn't ask about the mean, so I guess it really didn't matter, but it asks what's happening, what's the new standard deviation. So you have to take 5.76, plug it into this function, knowing that minus 100 does not affect standard deviation. If I had my little my little round thing that I could show you here. Multiplication affects the spread. Okay, so I'm going to multiply by 75, but then shifting it 100 shifts does not change the spread. All right, 18. So I actually computed. Now, I looked at this and I was like, oh, that's about symmetric. So I kind of did the standard deviation rule, but I checked whether you did the standard deviation outlier rule or the upper and lower fence outlier rule. Either one, they both had no lower outliers and at least one upper. I don't know how many upper. I just know that the max is an upper outlier. It's above the upper fence. The minimum is not below the lower fence. Okay? So the max is above the upper fence. So there's that one, or, however many more are in between the fence and it. And finally, this one is pretty mind blowing, also. Man, I had to do a lot of thinking on this one. Here we go. 25 pieces of data. First, this is a cumulative frequency chart, not cumulative relative frequency. So this is not percentages over here on the left side. Okay, so now I also want you to notice that when I needed to find out how many pieces of data, how many games occurred in each one of these bars, because it's cumulative. So that's adding. So I can tell right here, look, the 2 bars or 2 games went 3.5 innings. Okay? Now, for this next one, how many were added to it? Well, 3 were added to it for a total of 5. So 3 games were 4 innings long. Okay? Now it added one more. So 1 game was 4.5 innings long. Then it added 2 more. So 2 games were 5 innings long. And so on. This added up 5 more innings. 5 innings were 5 games were 5.5 innings long, and so on. I kind of wasn't sure exactly how much this was because it was just so much, but I knew that look here, this flat, there was no increase here, so no additional games were 6.5 innings long. But I did see this. One additional game was 7. All right, so I kind of subtracted, and that's how I was like, okay, well, then I think that's 11 is what's left. So there were 11 games that were 6 innings long. So that was the most common for sure. Coming over here, the median game is 5 innings. Well, you know what? The median is the 13th piece of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That puts the 13th game right here. That is what? So is it 5.5? So I'm confused because I thought that I checked this on something else and it showed that bar was 5. So I'm going to have to go check that. What the heck is going on? I could have sworn when I pulled that up on Cami a minute ago, it showed it to be 5. Okay, so let me check that. All right, this is messing with my mind here. Okay, so let's take a look and see what's going on. Here it is. Let me go to that number 20. Oh, yes, look at there. 5, dang it, that median is not 5 innings long. No, so that right there is wrong. It is not, it is not 5 innings long. It's 5.5. That median falls in here. It's 5.5 innings long. Yikesies. So what's the answer? Let's go through it. 14 games lasted 5.5 innings? No. I got that there were additional, What is going on here? Did I change this or something? Okay. So an additional 5 games lasted 5.5 innings long. All right. This says a majority of the games lasted 6 or more innings. Okay, a majority. So see, I think also here majority means more than 50%. Well, look, this section 11, that's 12 games. 12 games is not a majority. So I'm going to say no on that one. And D says the distribution of the game lengths is severely skewed to the left. No, that's not what's happening. I think it might be skewed to the left because if you look at these numbers, 2, 3, 1, if you were to look at the original plot of this, it's hard for me to draw what's happening. But if you were to look at this original plot, it would be here's your 11, and then here's nothing, and then here's your 1. Okay, there's your 11, and then you got 5, and then you got 2, then you got 1, then you got 3, and then you got 2. So I'm thinking that it might be skewed. Severely skewed? I don't know. All right, and this last one, let's keep going and looking. So I'm thinking that's not true though. Games lasting more than 6 innings occurred least frequently. Okay, so that's these ones, 0 and 1. And so then I'm saying to myself, well, yeah, I know that 6.5 innings is definitely the least, but the one lasting 4.5 innings was also only 1. So, brr, what's the best answer? What is the best conclusion? Grr, I hate those. I mean, how much do we want to quabble over severely skewed left? I mean, I'm thinking it is skewed left because I've got 1 and then I've got that one and then da da da. So I'm thinking now I'm gonna have to go with D. So debate me on it and defend, and we'll see what we can come up with. But very interesting, mind perplexing problem there. I hope kind of going through some of those has helped you. I know that these have really challenged me on some of my thinking, and I love that. I love when I have those problems that are just really throwing me for a loop that we can debate, and I can't wait tomorrow when I get into class to have some of my students debate me on these. So we'll see how that goes. All right. Hope this helped you. Hope you're ready for your quiz today over these kinds of concepts. I can tell you they're not going to have some as hard as that one right there on there. All right. Good luck to you.